Okay, on to our last proof. Let's see here. We have circle O in our given, and that tells us that OH and OF are congruent because this is the center of the circle. Well, you know what I mean. The diagram might not always be correct. So OH is congruent to OF because radii are always congruent. OG is perpendicular to FH. That tells us this is perpendicular. So OG is perpendicular to FH. So you can mark that because perpendicular lines make right angles or intersect at 90 degrees. Get that out of the camera. Also, we can tell that GO is congruent to GO. This is from the reflexive property, and since HGO and FGO share GO in, they both share this side. It's a common side for both. And this will give you, well, technically this gives you angle, side, but you can't do that. It really is RHL. It tells you you have the right angle in a right. This only works in right triangles, obviously. You have the right angle, you have the leg, and then you have the hypotenuse. Since you know the hypotenuses are correct, that they're congruent. You also know, or no, you know the hypotenuses are congruent from circle O because they're radii. You know that GO is congruent to itself because they share the common side and the reflexive property. And you know FGO and HGO are right angles because of the perpendicular lines in the given. So that would leave you with RHL. That proves that triangle FGO is congruent to HGO. But that's not what we're trying to prove. We're trying to prove that angle FOG is congruent to angle HOG. And you know that because of CP/CTC, or corresponding parts of congruent triangles are congruent. And one other thing I wanted to point out, that this can be categorized as an isosceles triangle, which would also mean that this is congruent to this because of the base. So since the two sides are congruent, it makes the two base angles automatically congruent to each other. So that would have been a much easier way to solve it, but I wanted to put both out there. So that proves that angle FOG is congruent to HOG because of either isosceles triangles' bases are congruent, or because RHL and corresponding parts of congruent triangles are congruent. And that's number 5.